So what we'll be taking a look at in this multiple part series is annuities. So this is part 1 of that series. So in the annuities topic, we're going to be looking at a number of things, and this includes the definition of an annuity, the calculation of present and future values of an annuity. We're going to be looking at deferred annuities, as well as perpetual annuities and what we call annuity dues. We'll be looking at how to calculate equivalent annuities, and then looking at how we use annuities to compare multiple projects. So looking first at the definition of an annuity. So an annuity is simply a series of identical cash flows. So if we take a look at this diagram here, we can see that an annuity is simply, in its most simplest form, a cash flow that starts in year 1 and continues for a set period of time, so in this case for 5 periods, and is the same cash flow every period. So I've just denoted this A. So that's simply what we're talking about as an annuity. So to start off with, we've just got the basic formulas here. So you can see that this is the present value and future value of an annuity. Now, in its most simplest form is what I say, that the cash flow starts at year 1. If this doesn't occur, we've got a deferred annuity, and we'll be taking a look at that a little bit later on. But in this case, A is just your annuity, so your cash flow amount. R is your interest rate, and T is the number of periods. Your present value will calculate the value of the annuity in the period before the first cash flow. So in the most simplest form, it will calculate the present value in year 0. The future value will always calculate the value of the annuity in the year of the last cash flow, or the period of the last cash flow. So it'll calculate it, in this case, in period 5. So that's an important thing to remember. Now, what is important is that R and T must be in the same time unit as the cash flows. Now, what do I mean by that is that if we've got a cash flows occurring at the end of each month, then the interest rate must be compounded monthly and must be a per month rate, and T must be in months. So a lot of the times it's easier to calculate T as just being the number of cash flows. That's all that it means. So although it's the number of periods, because you've got a cash flow occurring at the end of each period, it's just going to be the number of cash flows. So if you've got a cash flow occurring every month for 5 years, you're going to have 12 times 5, so 60 cash flows. And if your interest rate was 12% per annum compounded monthly, you'd then have a 1% per annum per month compounded monthly rate, and that would be the rate that you'd have to put into the formula. Now, it can get a bit confusing, and we'll look at it in more depth in the effective interest rate topic, but just keep that in mind for now. So the first sort of complication that we can get in annuities is what's called a deferred annuity. And that's simply what I was talking about before, is if the first cash flow doesn't occur in period 1. So just looking at this diagram here, we can see that the annuity is simply being deferred. It's going to start in period 3 instead of period 1. So there's 2 methods to deal with deferred annuities, and it's simply a personal choice. You'll get the same answer regardless of which method you use. So in some questions it may be easier to use one of the methods, but at the end of the day, it's just whatever you feel more comfortable with. So looking at method 1, what it does is calculate the present value of the annuity first, and then take that present value to year 0. So if we look at this above question here, calculating the present value of this annuity will calculate it in this period, period 2, because remember it calculates in the period prior to the first cash flow. So then, in order to take this back to year 2, we'd then have a single cash flow and taking it back 2 periods. So that is simply just a normal compound interest problem. So if we take this and assign some numbers to it, so assume we had $100 annuity and it's invested at 10% per annum. Now remember, these cash flows at the end of each year, so 10% per annum is fine. We don't have to worry about that. So putting it into this formula first, we have $100, 5 cash flows, 10%, so we get $379.08. But remembering, this is the present value in year 2. So to then calculate it at year 0, it's a simple compound interest problem, and we've got it at $313.29. So that's method 1. Now method 2 is slightly different, and what it does is it takes this and splits it up into what we call almost 2 annuities. It's the method of superposition. So we could say that this cash flow is simply a cash flow starting from year 1 through to year 7, but then minusing these 2 cash flows here. So you can see that minus that is just going to give you 3, 4, 5, 6, 7. So all we have to do then is calculate the present value of these annuities. And because they all start in period 1, we don't have to worry about any sort of complications. So we've got 100, 100, and then 10% per annum if we're keeping the numbers from the previous problem. And then in this case we've got 7 cash flows, and in this case we've got 2. And just remember the minus sign because you're doing this minus this. And we get $313.29. And you'll notice that's the same as method 1. So that's it for this session. In the next session we'll be taking a look at perpetual annuities and an annuity due.